Hello everyone, my name is Muhammad Amri bin Muhammad Yunus. We are basically from the Division of Control and Mechatronic Engineering, Universiti Teknologi Malaysia. So basically today I would like to share some information regarding our research outcome entitled Sensor for Cooking Oil Discernment based on Planar Electromagnetic Sensor. So cooking oil is one of the major commodities in Malaysia. So these high quality cooking oil are being purposely adulterated by irresponsible manufacturer in many ways. One of the way is by adding it with low quality cooking oil and then claim as a high quality oil. And worst case scenario, they recycle the cooking oil. Basically, how we can measure the actual quality of the cooking oil, especially palm oil, by measuring the actual or signature of the organic compounds. So there are many ways how to do it. One of the method is by using indicator based on the signal or energy response, such as using the infrared spectroscopy or microwave spectroscopy. But basically, this method uh, is based on the accuracy of this method based on the experience of the operator. Okay, and there are other more accurate method like uh, gas chromatography or high performance liquid chromatography, but this method is relatively expensive. So we see this as an opportunity to use planar electromagnetic sensors in this application. Um, so basically, planar electromagnetic sensor consists of two main sensors known as the meander and interdigital type sensors. So when current flow through the meander sensor, it will produce magnetic field, and it basically used to detect or estimate the magnetic material. While the interdigital type sensor is used to detect dielectric materials. So when we combine these two sensors, we get electromagnetic sensor. The basic design of the sensor in our project, okay, is having a two sensor, which is meander and interdigital. So the overall dimension of the sensor is basically 20 times 20 millimeter, and then having the meander with 5 loops, and the interdigital comprise with 5 negative electrode and 4 positive electrode. So there is a ground plate located at the bottom and under the interdigital sensor, and then the ground plate dimension is around 10 to 10 mm times 8 mm. Okay, and shows the PCB. Okay, the sensors manufactured on the PCB. Uh, so these sensors so the sensor consists of a sensing array. So having three identical planar electromagnetic sensor. Namely S1, S2, and S3. Okay, so basically we use a connection or solder the connection, and then connect to the impedance analyzer. So in in principle, when the cooking oil sample is subjected to an external electromagnetic field, the active electrical components, which is the dielectric poles and the mobile ions, interact with the external electromagnetic field. So the external electromagnetic field is partly neutralized, and then the response can be seen from the impedance versus the frequency graph. Okay, so this partly neutralization process is unique among other type of cooking oil sample. Uh, so in our experiment, before we conduct, we run the experiment. So we calibrate the impedance analyzer or Hioki impedance analyzer by performing short and open test calibration. So this procedure of the actual process began by immersing the coated electromagnetic sensors into the field separated oil column as shown in this figure, and the impedance analyzer basically was set at low constant peak-to-peak voltage of 1 volt sinusoidal signal with a frequency sweep of 100 Hz to 5 MHz with 801 data point on a log scale. So the impedance for each set of the measurement was taking 30 times uh, to ensure the repeatability and reliability of the measurement. So and then after each measurement, we properly clean and rinse the container using soap to ensure there is no compromise in each measurement. So in the sample preparation, we prepared two type of samples. First, for the characterization, using 4 type of cooking oil, such as sunflower oil, corn oil, palm oil, and canola oil. And then for each sample, we prepared 1 liter of volume. Next, we use a commercial palm oil cooking oil sample as a major focus for adulteration. So the cooking oil was purposely adulterated with the corn oil cooking oil sample using ultrasonic bath, and the range corn oil cooking oil concentration are 20%, 30%, and 40% from the total volume of the palm oil cooking oil, which is at 200 milliliter. So this figure shows the overall impedance response for the characterization of 4 different types of commercial cooking oil sample using the S1, S2, and S3 sensors. So in general, as you can see from the impedance, the impedance for all cooking oil type, so basically is decreasing when the frequency is increasing. Okay, and the uh, phase basically remain at capacitive characteristic between 100 Hz to 10 kilohertz, and then slowly to the capacitive characteristic slowly to decrease after 10 kilohertz. But when we replot the data, okay, using the real and imaginary impedance versus the frequency, you can see especially in the real value, so the distinguishing between the uh, cooking oil sample can be clearly seen. So in general, this is the um, the impedance and phase response for the adulterated sample. Okay, in general, the impedance is also decreased. Okay, when the frequency is decreased. Okay, and then the phase remains the characteristic remain uh, capacitive until 100 kilohertz. So at first glance we cannot see or distinguish clearly, but actually when we run the further analysis, we can uh, clearly distinguish this adulterated sample by estimating the um, electrical parameters, which we will discuss later. So in this project, okay, we develop a model for the system, which can be also be represented by this equation, okay, whereas L is the inductance of the meander, Re is basically the material sample resistance, and Ce is the capacitance of the material. So the idea, okay, is to use this model, okay, and then we estimate the L, Re, and Ce value based on the experimental data. So after we estimated the Re, Ce, and L value using the EIS spectrum analyzer software, then we calculate the electrical parameter value, which is the conductivity and the relative permittivity, using these two equations. So for the conductivity, the equation is equivalent to 1 over kappa multiplied with Re. Kappa is basically the geometrically correlated constant of the interdigital sensor. And for the relative conductivity, the equation is Ce over kappa epsilon naught. Epsilon naught is the basically is the free space permittivity minus epsilon s. Epsilon s is the substrate of the PCB, which is equivalent to 0.5. So these are the result, the conductivity and the relative permittivity for the characterization of the cooking oil, different type. So as we can see, the different value of the conductivity, okay, for measured by each sensor, shows that the sensor can distinguish between the different sample. So basically, and also for based on the relative permittivity value, there is a significant uh, 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 value difference, okay, between different type of cooking oil sample. So in our experiment, okay, the relative permittivity and conductivity value for the 30 measurement of each cooking oil sample were estimated. So the highest relative permittivity value obtained was the corn, okay, oil, cooking oil, which is okay, around 2.97, where sunflower oil is the lowest at 2.84, okay, value. While for the adulterated samples, as we can see uh, in the figure below or the chart below here, the difference of the relative permittivity and conductivity value can be significantly seen, where the values of the conductivity and the permittivity decreases when the concentration of corn oil increases or the adulteration increase. Okay, therefore it can be concluded here, the result shows that the feasibility of the planar thermosensitivity in distinguishing several type of commercial cooking oil through the electrical estimated electrical profile. As a conclusion, so our work showed that the impedance matrix sensor combined with the electromagnetic impedance spectroscopy technique can distinguish several types of cooking oil. And then furthermore, this paper also present the conductivity and relative permeability of the cooking oil sample using the estimated value as a high accuracy at around 92%. So with that, I conclude my presentation. Thank you for your attention, and then thank you very much.